The Tunguska Event, Unraveling the Greatest Explosive Mystery in History. Hello, everyone. Welcome back to our channel. Today, we're diving deep into one of the most enigmatic and explosive mysteries in modern history, the Tunguska Event. Buckle up as we explore the details of this colossal explosion, investigate the theories that have emerged over the years, and understand its scientific significance. Don't forget to subscribe and hit the notification bell so you never miss our fascinating content. Introduction. It was a serene summer morning in Siberia, Russia, on June 30th, 1908. The sun shone brightly, and the local Evenki people went about their daily routines. However, at precisely 7:17 a.m., a tremendous explosion shattered this tranquility. An enormous blast was felt and heard over a vast area, leading to one of the most significant and puzzling events in scientific history, the Tunguska Event. The explosive event, the initial explosion. On that fateful day, a brilliant object, brighter than the sun, blazed across the sky. Before anyone could react, a massive explosion occurred, sending shockwaves throughout the region. The explosion was so powerful that it flattened over 2,000 square kilometers of forest, creating a scene of unprecedented devastation. Trees were uprooted and scattered in a radial pattern, and the entire area was engulfed in a massive shockwave. Witnesses described the event as a sequence of loud booms and a fiery explosion. The impact was so intense that it could be felt as far away as Europe, with seismographs across the world registering the disturbance. The energy released was estimated to be equivalent to 10 to 15 megatons of TNT, or roughly 2,000 times the power of the atomic bomb dropped on Hiroshima. The environmental impact. The immediate aftermath was catastrophic. The once dense forest was left in ruins, with trees thrown like matchsticks and scorched to a crisp. The heat was so intense that it ignited fires, creating a smoldering wasteland. Despite the destruction, there were no recorded fatalities among the local Evenki people, likely due to the event occurring in a sparsely populated region. Eyewitness accounts and early observations. Accounts from local inhabitants. The first detailed reports of the Tunguska event came from the local Evenki people who lived in the area. Their descriptions were vivid and chilling. They spoke of a bright fireball streaking across the sky and a series of thunderous explosions that shook the ground. Some described seeing a pillar of fire and felt a powerful blast that knocked them off their feet. One account described how the Evenki hunter Semyonov Ivanov saw the sky split in two, with fire and smoke spreading rapidly. The sheer force of the explosion was so overwhelming that it was felt miles away. The witnesses reported that the explosion seemed to last for several seconds, followed by a complete silence as the dust settled. Early scientific observations. The Tunguska event was not immediately understood, and it took years for scientists to begin investigating the cause. Initial theories ranged from volcanic eruptions to meteorite impacts. The event's remote location and lack of a clear impact crater complicated early scientific efforts to determine the cause. Scientific investigation. The first expeditions. In 1927, Russian scientist Leonid Kulik led the first major expedition to investigate the Tunguska site. Kulik's team found an area of flattened trees but no crater or fragments of a meteorite. This led Kulik to hypothesize that the explosion was caused by a meteorite that had exploded in the air, a theory that would later gain widespread acceptance. Kulik's expedition revealed the extent of the devastation and helped establish the groundwork for future research. He observed the radial pattern of the tree falls and the absence of a crater, which strongly supported the airburst theory. Later research and discoveries. In subsequent decades, several other expeditions were conducted, but they faced numerous challenges, including the harsh Siberian climate and the difficulty of accessing the remote region. During the Soviet era, scientific interest in Tunguska was intermittent, but the discovery of additional evidence continued. Recent research has used advanced technology to study the Tunguska event. Satellite imagery, ground-penetrating radar, and computer simulations have provided new insights into the explosion's dynamics and effects. Scientists have discovered small fragments of extraterrestrial material in the region, further supporting the meteorite impact theory. Theories and explanations. Meteor impact theory. The meteor impact theory is the most widely accepted explanation for the Tunguska event. According to this theory, a comet or asteroid entered Earth's atmosphere and exploded in an airburst. The object was estimated to be between 50 and 100 meters in diameter. As it traveled through the atmosphere at a high velocity, it encountered increasing pressure, which caused it to disintegrate and explode before reaching the ground. This airburst would have released an enormous amount of energy, equivalent to several thousand tons of TNT, which accounts for the widespread destruction and lack of an impact crater. The explosion caused a shockwave that flattened trees over a vast area, creating the distinctive radial pattern observed at the site. Alternative theories. While the meteor impact theory remains the most widely accepted, several alternative theories have been proposed. Nuclear explosion theory. Some have speculated that the Tunguska event was caused by a secret nuclear test. However, this theory is not supported by evidence, as nuclear technology was not available in 1908, and the explosion's characteristics do not match those of a nuclear detonation. Natural gas explosion. Another theory suggests that a release of natural gas from underground reservoirs could have caused the explosion. This theory proposes that a large amount of methane or other gases accumulated underground and ignited, leading to a massive explosion. However, this theory lacks solid evidence and does not account for the observed characteristics of the explosion. Antimatter collision. A more speculative theory involves the collision of antimatter with normal matter. This would result in a powerful explosion due to the annihilation of matter and antimatter. While intriguing, this theory is highly unlikely given the lack of supporting evidence and the rarity of naturally occurring antimatter. Cultural and scientific impact. Influence on popular culture. The Tunguska event has captured the imagination of people worldwide and has inspired numerous works of fiction. From novels to films, the idea of a catastrophic explosion caused by extraterrestrial objects or unknown forces has become a popular theme. The Tunguska event has appeared in science fiction stories, video games, and conspiracy theories, reflecting its enduring fascination. Scientific advancements. The Tunguska event has had a significant impact on scientific research. It spurred the development of new fields of study, including planetary defense and asteroid impact monitoring. The event highlighted the potential dangers posed by near-Earth objects, NEOs, and led to the establishment of monitoring programs to track and mitigate potential threats. In the decades following the Tunguska event, scientists have developed sophisticated tools and techniques to study and predict asteroid impacts. Organizations such as NASA's Planetary Defense Coordination Office, PDCO, work to identify and track potentially hazardous asteroids to prevent future disasters. Recent expeditions and discoveries. Advances in technology. Recent technological advancements have provided new insights into the Tunguska event. Satellite imagery has allowed scientists to map the impact area in detail, while ground-penetrating radar has helped identify potential impact sites. These technologies have also revealed previously unknown features of the event, such as subtle variations in soil composition and the presence of extraterrestrial material. Ongoing research. Ongoing research continues to shed light on the Tunguska event. Scientists are using computer simulations to model the dynamics of the explosion and its effects on the environment. These simulations help to refine our understanding of the event and improve our ability to predict and mitigate similar events in the future. Lessons learned. The Tunguska event serves as a powerful reminder of the potential dangers posed by cosmic objects. The event underscores the importance of monitoring space for potential threats and developing strategies to protect our planet. The scientific community continues to work on improving detection and mitigation technologies to ensure that we are prepared for future impacts. Final considerations. More than a century after the Tunguska event, the mystery of what caused the massive explosion continues to intrigue and inspire. While many questions have been answered, ongoing research and exploration ensure that we continue to learn more about this extraordinary event. The Tunguska event remains a testament to the power of nature and the importance of scientific inquiry. Thank you for joining us on this journey through one of the greatest mysteries in history. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more exciting content. We'll see you in the next video.